On this problem, I want to go through and explain how to complete it. It is a complex problem and it does involve using a conversion factor that is specific to that situation. So recall conversion factors just tell us how two units are equivalent to one another or how they're related to one another. It can be two of the same type of units of measurement or different types of units of measurement. And so with that in mind, when you're dealing with the word problem, go through and read the problem and then go back and dissect it, meaning that you're picking out the information that is provided in that problem, determining what it means, and also figuring out what is being asked. So the problem says if the caffeine concentration in a particular brand of soda is 3.41 milligrams per ounce, drinking how many cans of soda would be lethal? Assume that 10.0 grams of caffeine is a lethal dose and that there are 12 ounces in a can. So go back and pick out the information, look at what was provided. First line tells us if the caffeine concentration in a particular brand of soda is 3.41 milligrams per ounce. And I'm going to stop there. So 3.41 milligrams per ounce. Sometimes you're going to have measurements that have multiple units. Listen to how you're reading it, and that tells you how to set that unit up. In this case, because it's telling us about the caffeine in the soda, it's telling us how these two things are related. So it's really a conversion factor that applies to this specific situation. Some conversion factors apply only to that situation. Some conversion factors are constant. So for instance, 12 years being the same as 1 decade, that's constant. But in this case, the amount of caffeine in this soda, that's for this one situation. So when we have conversion factors that apply to a situation, they're going to be given to you within that specific problem. And so here again, the caffeine concentration in the soda is 3.41 milligrams per ounce. The way that you read it tells you how to separate your conversion factor. Recall, we show conversion factors as fractions, so how we read that tells me how to separate it. So 3.41 milligrams per ounce, so I'm going to write it as 3.41 milligrams per, just tells me how to separate my fraction. So per ounce. So I can just show it as ounce, or I can put a 1 in front of it because this is how many milligrams are present for every 1 ounce. I can take it a step further because it told me that the caffeine concentration in the soda, so this milligrams is telling me about the caffeine, and that's in every 1 ounce of the soda. So that is information provided by the first part of that line. So then it says drinking how many cans would be lethal. So we're really trying to figure out how many cans of soda. And so from there it says assume that 10.0 grams of caffeine is a lethal dose. So I'm going to just show that. I'm writing down the information that's provided. So 10.0 grams of caffeine. So that's our lethal dose. And then it says that there are 12 ounces in a can. So really, I could have taken the last two that we did, I could have taken those a step further. So when we say that there are 10 grams of caffeine, or it says 10 grams of caffeine is a lethal dose, so I can set that up as a conversion factor if I choose. I can say that for every 10 grams, it should be 10.0 grams. I can say that this is the same as 1 lethal dose. So we can derive a conversion factor based on that one situation. Same thing with the 12 ounces. We were told that there are 12 ounces of soda for every 1 can of soda. And so we have these 3 pieces of information. We're trying to figure out how many cans. And so from there, we've determined what was given, we've determined what was needed. We were actually provided with the relationship between the given and the needed within this problem. So now we have to set everything up and arrange it. When you're setting up your conversions, you always want to start with the measurement that is provided. So we were provided with how much caffeine was in the soda. We were provided with how many ounces were in the can. But the goal of the problem is that we're trying to figure out how many cans of soda would be lethal. So in order to figure out how many cans of soda would be lethal, what we're starting with is what is our lethal dose. So we have that 10.0 grams of caffeine is the lethal dose. So basically what we're trying to figure out is based on these grams of caffeine, how many cans is that equivalent to? So let's set it up. So we're starting with grams of caffeine and we're trying to figure out cans of soda. So I'll write those conversion factors again just so that we remember what they were. So 3.0 milligrams per ounce. We also had the 12 ounces per 1 can. And then we had our lethal dose, which is what we're going to start with. So you're starting with your lethal dose. 10 grams of caffeine. So the goal is to go from grams to cans. So I have to ask myself, is there a direct relationship between the gram and the can? And there's not. If we look at our conversion factors, we have milligrams and ounce. We have ounce in can, but we don't have grams to can. So what that tells me is that I cannot go straight from grams to cans. Instead, I have to figure out, is there some unit that both of these can be related to, and that would allow me to go from what was given to what was needed. So if I look, I had ounce in milligram, I had ounce in can. So ounces would allow me to compare to the milligram, and ounces would allow me to compare to the can. But I don't have milligram. I have grams. So then you have to ask yourself, is there something else that I could use? So if I could go to milligrams, then I know I can go to ounces, then I can go to cans. So this is a dimensional analysis problem that involves using multiple conversion factors. And so by planning out how to go from what was given to what was needed, you'll know how many conversion factors and you can identify how to arrange them so that we can go throughout the target. So everywhere where there's an arrow represents the use of a conversion factor. We have two conversion factors that are shown, but we don't have the one shown for what would represent what I have shown as A. And so when we look, if we're trying to go from the gram to the milligram, I have grams of caffeine. So ask yourself, what is the direct relationship between gram and milligram? And you would fill in those numbers. At that point, your grams will cancel to leave you with milligrams. So then we would be here. Then we will plug in the conversion factor for B that relates the milligrams to the ounces. So I would call this one B. This relates the milligrams to the ounces. So you would arrange that as it should be. So this is where A is, this is where B is, and then once you have that, you would do the same thing for C to go from ounces to cans. So this one I'll call C because it relates the ounces to the cans. If you set it up properly, your units will cancel out, and at the end, what you would be left with is simply cans of soda that will be required in order to have a lethal dose of caffeine. So I don't want to go through and actually do the entire thing. I want to make sure that you're able to set it up, so that should help you to get started, and from there you should be able to complete the problem. So I hope this helps. If you still have any questions, please let me know. Thank you.